For the second part of mechanics, I'm going to be looking at circular motion. Okay, so when I say circular motion, is when a object is moving in a circular motion. It's basically literally is what it is. So in circular motion, we have a couple of equations I'm going to run through really quickly. Okay, so we have C on your formula sheet, FC equals to mv squared over r, and we have AC equals to v squared over r. So what are these so what exactly are these formulas, okay? So FC here, that's FC is actually the centripetal force, okay? So the force acting due to the circular motion. So centripetal force, M is mass in kgs, V equals to velocity, measured in meters per second, and R is the radius of the circle, which is measured in meters. Our AC is the centripetal acceleration, so the acceleration acting on the object, okay? So that's the centripetal acceleration. Okay, so once again, V is velocity measured in meters per second, and R is radius measured in meters. So these are the two main equations, okay, just for the circular motion, okay. So the main part of circular motion, okay, so it's I guess I can say it's mainly explanation based, okay, and drawing some diagrams, okay. So I'm gonna roll some of it. I'm gonna start off with drawing the diagrams. So I'm gonna start off with labeling some simple diagrams, okay. So in this diagram, we're gonna label the FC, and we're gonna label the V, and we're also gonna be labeling the acceleration, okay. So the FC will start off with centripetal force. Centripetal force, okay, so that's always acting from the object into the center, okay. So let's say point A is where our object is, so we'll say this is where our object is, and we're gonna have draw our centripetal force, okay, the direction. So our direction is always acting towards the center from the object, okay. So basically what I mean from that is from the object towards the center of the circle, that's gonna be our F of C, okay. And our instantaneous velocity, okay, that is, or let's say this is moving in a clockwise direction. Let's say this is clockwise. Our velocity is always 90 degrees to the object, okay. So when I say 90 degrees, it's in the direction of the motion. So it's moving in the clockwise direction. So therefore, our velocity will be acting 90 degrees. Sorry, it will be acting 90 degrees. 90. So it's basically the centripetal force and the velocity, so this is velocity, they're perpendicular to each other. So perpendicular. And the acceleration, okay, the acceleration is also acting towards the center, okay. So if I say acceleration will also be acting towards the center of the circle. So basically that's FC and A. So FC plus A. Alright, so that's basically pretty straightforward. That's how you would be labeling a simple diagram, okay, of a centripetal force, velocity, and acceleration. It's pretty straightforward. Okay, so for the next few clips, I'm going to be doing some calculations of centripetal acceleration and centripetal force. Right, so in this part of the video, I'm going to be covering how to calculate the centripetal acceleration of an object. Alright, so we have a ball, and it's moving at a constant speed of 5 meters per second. The radius of the circle is 1.59 meters. Note down what we have. We have a constant speed of 5 meters per second, so V equals to 5 meters per second. The radius of the circle is 1.59 meters, so R equals to 1.59 meters. What is our AC? This question is it's pretty straightforward. Okay, you're looking at your formula sheet. A of C equals to V squared over R. So AC equals to 5 squared divided by 1.59. So AC therefore would give you, calculator work, so 25 divided by 1.59. Sorry. So 25 divided by should give you your centripetal acceleration should come out to be 15.72 meters per second. And that's how you would be calculating the centripetal acceleration of a ball. Alright, for the next clip, I'm going to be showing you how to calculate the centripetal force on the ball, which is a bit trickier, but it's manageable. Alright, next video. Alright, for this clip, I'm going to be covering how to find out the centripetal force acting on an object, given the radius, time for one rotation, mass, and circumference of a circle. Alright, so we're going to immediately drop down our what we know. So we know r equals to 2 meters. We know the time for one rotation, so time equals to 1.5 seconds. Our mass we know is 10 kgs, and we know that our circumference equals to 2 pi r. And we also know that Fc equals to mv squared over r. Alright, however, the problem is, okay, we have m and r. We do have that. However, we don't have v. We need to use the time and circumference to find what our v is. Okay. So we're going to figure out what our circumference is, and we're going to see using how long it takes to make one revolution of the circle to find out what our speed is, okay? So basically, circumference equals to 2 pi times of 2, which is equal to 4 pi. So the ball travels 4 pi distance in 1.5 seconds. Okay, so you know that, what am I saying? So you know that v, v equals to distance over time, okay? So we know that v equals to d over t. So therefore, v we know is 4 pi over 1.5. And if you plug that into your calculator, so 4 pi over 1.5, that gives us our speed as 8.377 meters per second. So now we can use this and substitute back into our Fc formula to find our Fc, okay, our centripetal force. So Fc equals to m, which is 10 times of 8.377 squared, divided by our radius, which is 2. So if we plug that into our calculator, so 8.377 squared times 10 divided by 2. You should get your Fc as 350.87 newtons. And that's basically how you would calculate a centripetal force given the information that the radius, time for one rotation, mass, and circumference of a circle. For the next question, next question, but for the next clip, I'm going to be showing you some some more discussion type questions that they will throw at you. So, next video. Alright, so this is a really important application type question. So explain why a horizontal force is needed on the ball, even though it was moving at a constant speed. Alright, so this question there's a horizontal force because there is actually an acceleration on the ball despite it moving at a constant speed. And it's because the magnitude stays the same, however the direction is always changing. And because the velocity is a vector quantity, both direction and magnitude, so therefore the velocity is changing and therefore there's an acceleration. And whenever there's an acceleration and there's a mass involved, then there has to be a force acting on the object. So how are we going to answer this question? Okay, so the first statement we always make is velocity is a vector quantity. It's a vector quantity measured in both magnitude and direction. Okay, it's measured in both magnitude and direction. Okay, although the magnitude of the ball, magnitude of the velocity of the ball is the same. Although it's the same, so it's constant. The direction is always changing due to circular motion. Okay, so it's always changing. The direction is always changing in circular motion. Therefore, there is an acceleration. Therefore, there has to be an acceleration on the object. So now we say because there's an acceleration, there is an acceleration on the object, on the ball, okay, on the ball, and F equals to ma, and the ball has a mass, therefore there has to be a force acting on the object. So that's what your answer should look like. Okay, so you're gonna define what velocity is. Okay, so velocity is a vector quantity. You're gonna say that although the magnitude is the same, the direction is always changing. And because the direction is always changing, therefore there has to be an acceleration on the ball. Because there's an acceleration, you link that back to F equals to ma, and because the object has a positive mass and there's a positive acceleration, then there must be a positive force acting on the object. And that's basically how you would be explaining this type of questions, okay? Alright, so for the next little clip, okay, will be explain why the object will move at a tangent to the circle after the loss of centripetal force. Alright, so a perfect example for what I was just talking about with the loss of centripetal force, okay, is perfectly described in this question. So explain clearly with reasons what would happen to the car if the road was icy and could not provide any of the force, okay. So if there's no centripetal force, okay, so that means no force means that the velocity must remain constant. And because the velocity is constant, that means there's no change in direction. So that means that the car will immediately start to travel in the direction of its instantaneous velocity. So basically that's all it is to this question, okay? So if the road was icy, which is frictionless, there would be no centripetal force. Right, because there's no centripetal force, because there is no centripetal force, then there is no unbalanced forces acting on the object. So there are no unbalanced forces acting in the object, meaning that there cannot be a change in velocity. This means that the car would now have a constant velocity, both magnitude and direction. And as a result, the car will move at a constant speed at a tangent to the center of the circle. Alright, so basically you're saying why there's a loss of centripetal force, and then you're linking it back to no centripetal force, meaning there's no unbalanced force, and there's no unbalanced force, and the velocity must remain constant. And if the velocity remains constant, then that means that both the magnitude and the direction is constant, not changing, so therefore the car will be moving in the tangent to the center of the circle at a constant speed. And that would be how you would be answering this type of questions, okay? For the next video, okay, not next video necessarily, but for the next clip, I'm going to be covering another example of a explain question. So now I'm going to give you one final example of a type of question they could ask you in terms of the circular motion. So in this example, it says after a few rotations, the ball has the same radius of rotation but a shorter period. Explain what effect this will have on the horizontal force acting on the Jan. Okay, so basically, if the radius is the same and c equals to 2 pi r, that means the distance, so the c will remain constant. So c is constant, okay? However, if there's a shorter period and v equals to d over t, and t has decreased, that means well, technically v is proportional. T is proportional to 1 over t. And if it's proportional to 1 over t, that means if t decreases, then velocity will increase. And if velocity increases, then we're going to link that back to Fc equals to mv squared over r. And if v increases, we know Fc is proportional to v. Okay, and if Fc is proportional to v and v increases, then Fc will also increase. So now all we need to do is write this onto the paper and explain it in words, okay? So we're going to say that, starting off with describing the circumference of the circle. So because the radius is the same, the circumference of the circle will also be the same. It'll also be the same as a result. If v equals to d over t and d is constant, then v is proportional to 1 over t, meaning the period decreases, then the velocity will increase. Okay, so because now we're gonna link it to Fc equals to mv squared over r. Because Fc equals to mv squared over r, and m and r is the same, then Fc is proportional to v, and therefore as v increases, the Fc will also increase, meaning a high centripetal force. Alright, so that's basically how you would answer a question given some information. Okay, so you're going to link it back to your formulas, okay, and explain if this happens, what would this affect, and if this is affected, how would this affect this, and then you just keep linking it back until you get to what your final link is. Okay, so our final link is the horizontal force, which is the centripetal force, and the velocity. Okay, just making these links from the very start. Okay. Alright, so thank you for watching this video on centripetal motion, okay? Hope you enjoyed. If you have any questions, please leave it down in the comments below. Thank you for watching and see you all in the next one. Thank you. Bye.